11.6 Inverse variations. We already talked about variations before, and that was direct variations. That was when you set up the equation y equals k times x. Well, with inverse variations, they are going to be the equation y equals k divided by x. K is still going to be your constant of variation. This time x cannot equal 0 because you cannot divide by 0. So when we have an example of a problem that deals with inverse variation, it will say suppose y varies inversely with x. Write an equation for the inverse variation. You're starting with y equals 1 when x equals -2. So you set up your equation y equals k divided by x, and now you're going to substitute y, you're going to replace it with 1, and x we're going to replace with 2, which gives you 1 equals k divided by -2, and now we're solving for k. We have divided by, so we multiply by -2, multiply by -2, and we get -2 equals k. So that was where we took and rewrote our equation. Now when we did our direct variations, we're doing the same thing in inverse variations. So now if k is 2, -2 we put on the top over x equals our y, and we've written our equation. So the same thing happens in inverse variations. I'm going to be asking you on the test. The book doesn't ask you this part, but I'm going to ask on the test to find x when y is 40. So all you do is take your equation y equals -2x divided by -2 divided by x, and you're replacing y with 40. So 40 equals -2 divided by x, and now we're going to solve for x. So to do that, we'll cancel x by multiplying both sides by x, and we get x times 40 equals -2, and my x's would cancel. And now I have to divide by 40 on both sides, and I get x equals -2 over 40. Well, if we look at this, my y started here, x started there, the 40 and the x. Here x is now on the numerator and 40 is in the denominator. They just switched places. If you remember back to properties of proportions, anytime you have two equal fractions, we can switch on the diagonal. So the d can come to the numerator, the a can go in the denominator, and they will still remain equal fractions. So if you remember that process, you can quickly, when you have a 40 equals -2 over x, switch on the diagonal, and now x equals -2 over 40. And then simplify -1 over 20 or -5/100. And that problem is solved. So when we are asked to graph the inverse variation, so if I had y equals 12 divided by x, I want to be dividing by numbers that are multiples of 12. So I picked for my x values -12, -6, -4, -3, -2, -1, 0, 1, 2, 3, 4, 6, and 12. Because all those numbers I can divide 12 by. So if I go 12 divided by -12, I get -1. 12 divided by -6, -2. 12 divided by -4, -3. 12 divided by -3, -4. 12 divided by -2 be -6. 12 divided by -1 is -12. 12 divided by 0, I cannot do that. That is considered undefined. And you'll see what happens to undefined numbers in a second. 12 divided by 1 is just 12. 12 divided by 2 is 6. 12 divided by 3, 4. 12 divided by 4, 3. 12 divided by 6, 2. And 12 divided by 12 is 1. So when I go to plot those, at negative 12, I'm up at, or down at negative 1. At negative 6, I'm down at negative 2. Negative 4 is negative 3. Negative 3 was negative 4. Negative 2 was negative 6. Negative 1 was negative 12. And we get a curve going here. So the undefined, since I can't divide by 0, if I took this negative 12 and let's say I want to go further, so let's go if I want to go further this direction here, I would be at negative 1/2, and that gives me negative 24. My number keeps getting bigger and bigger here. As I get smaller, if I divide by 1/4, that would be a negative 48. If I went this direction, if I'm dividing by 24, I get 1/2. If I divide by 36, I'm getting my negative 1/3. So I'm staying smaller and smaller here, but I'm never going to reach 0. Same with this direction. So my undefined is a place that the line will never cross and will never make that number, because 0 times something is not ever going to give me 12. So now if I go to 1, gives me 12. 2 gives me 6. 3 gives me 4. 4 gives me 3. 6 gives me 2. And 12 gives me 1. So again, I get a curve up here. When I connect the dots, it will look like this. And you have graphed the inverse variation function. Anytime your x variable is on the bottom in the denominator, you're going to get two split branches, and you just need to make sure you're graphing both of them. The last type of problem today makes no sense to read this, but anyway, do the data in the table represent a direct variation or an inverse variation? Write an equation to model the data in the table. So I have my x and y given. X is 4, y is 15, 6 gives me 10, 10 gives me 6. So if I look at my two equations that we've been dealing with, a direct variation equation, y equals k times x, inverse variation, y equals k divided by x. Well, if I solve both of those for k, in this direct variation equation, I would have to divide both sides by both sides by x, and I get x divided by y equals k. This one I'd multiply both sides by x, and I get xy equals k. So what we're going to do is take our y and x values and divide them, and our y and x values and multiply them. So in my first one, if I go 15 divided by 4, 10 divided by 6, 6 divided by 10, are those equal to each other? No. So this is not a direct variation. If I look at my numbers when they're multiplied, 4 times 15, 6 times 10, 10 times 6, 4 times 15 was 60, 6 times 10 is 60, 10 times 6 is 60. They're equal to each other. This is an inverse variation problem. So now I write my equation. Go back up here, x times y was equal to my k value. So I can rewrite my equation, y equals 60 divided by x, and I have solved the third type of problem for today.